Okay, last video in the series, let's get into non-parametrics. So as we said, the test statistic for correlation is really going to be the Pearson product moment correlation coefficient. But if we violate the basic assumption of normality or linearity, we need to be able to have a non-parametric friend to help us determine what that correlation might be based off of mean ranked data. And this is the common theme of all non-parametric statistics that we've talked about this term, is that rather than relying on arithmetic, means and standard deviations, non-parametrics are nice because they allow us to take mean ranks or orders and to determine whether the mean ranks correlate or are different between each other. And so in the case of a Pearson product moment correlation coefficient, the first kind of non-parametric tool that we can use is called a Spearman's rho correlation. And so what the basic assumptions of a Spearman's rho correlation are is that it assumes that both the X predictor and the Y criterion variable are at least ordinal, interval, or ratio level of measurement. Whereas in a Pearson product moment, it had to be interval or ratio level of measurement. So we can include ordinal data in that way. The second assumption is that the predictor and the criterion both have to be paired, meaning that they are not independent observations, that the data that's collected from both the predictor and the criterion are from the same person within a short period of time. And lastly, we assume something that's known as a monotonic relationship, which basically dictates whether the variables increase in value together. As one variable increases, the other variable may also decrease. And so in a monotonic relationship, you can see that it really resembles a inverse or a negative correlation where one variable is increasing and the other variable is decreasing. And you can see that both in the first two schematics in the upper right quadrant of this slide. Whereas in a non-monotonic relationship, you can see that there's really no rhyme or reason in terms of how those variables are moving with each other. And so when you perform the statistical analysis, you might look at the correlations just like you would in a Pearson product moment correlation coefficient. And so you can see that the N represents the number of people who had their X predictor variable and Y criterion variables collected. The significance threshold two-tailed represents the alpha level and the observed significance that was obtained in that kind of data set. So here it's 0.035, and the correlation coefficient represents the degree to which the X is correlated with the Y, the actual Pearson product moment correlation coefficient, or in this case, the Spearman's rho correlation because it's based off ranked data. And so one of the things you'll notice that when you examine correlation coefficients is, look, if you look at English marks and English marks, well, that's the exact same data. And so, of course, it's going to be 100% correlated. The same is true for math marks and math marks. It's 100% correlated. So we're only interested in the off products here, where we're exploring English versus math and math versus English. And you can see that the Spearman rho here was 0.669, which is considered a relatively strong correlation in that way. The other thing, though, is that 10 people isn't very many people. And so when you have a small sample size, the other non-parametric equivalent that we can look to is called Kendall's tau. And so Kendall's tau is the more preferable correlation estimate when we have a small sample size. The assumptions to Kendall's tau is similar to Spearman's rho in that it assumes a monotonic relationship, and it assumes that both the predictor and the criterion are at least ordinal, interval, or ratio level of measurement. But that's it. So when you look at the correlation coefficient in the bottom left quadrant of this table, you can again see the sample size, the number of people whose data was collected, the significance value of 0.003, which tells us it's statistically significant, and the correlation coefficient itself of 0.535, which is above the 0.5 threshold, also indicating that this is a statistically significant relationship. So we went through this video series and we talked a lot about correlations. We introduced some new concepts and ideas about removing our understanding of independent variables and instead getting into predictor and criterion variables. We talked about variance versus covariance and how we ultimately determine the Pearson product moment correlation coefficient. We then went through the process for how we move through that statistical analysis procedure. talked about the contingencies that are put into place when we have more than one predictor and need to use zero order, partial, and semi-partial correlation coefficients. And then finally, we ended with this video, which really kind of brought everything back together and gave us two non-parametric equivalents to use these data if the assumptions to the violations were made. So this is going to be a really important component for how we look ahead into one of the last lecture videos for the term, which is based off of linear regression. And so we're going to use a lot of the knowledge, skills, and abilities that we gained from this lecture series to help inform how we move forward with our regression series. Hope this video was helpful. If you have any questions, feel free to reach out to me, come to office hours, do both, whatever works best for you. And we'll see you in the next video with regression. Take care.